Welcome to solverfy.
Okay, question 2.35. We have this insect, froghoper or something, that can jump and accelerate at 4 kilometers per second. Write these values down. 4 kilometers per second squared, rather, over a distance of 2 millimeters. And we assume the acceleration is constant, so we want to find the velocity that the insect takes off with, how long that takes in time, and how high it can jump total. So if we think about, we have kind of a few different coordinates going on here. This is the way I like to think about it. So let's call y0 or y0 the location that the insect is at when its legs are not extended, right? So that's just its normal height. When its legs are completely extended, it will be at height y1. So anything higher than that, and it will have left the ground. And let's call the height above that, but it's called the max height it can jump to, y2. So we're trying to find the max height it can jump, which is essentially the difference between y2 and y1. So it's going to make sense for us to say y1 equals 0, right? So y1 equals 0. That means y0 or y0 is negative 2 millimeters. So it's 0.002, yeah, meters. Okay. So that may be slightly confusing, but it will work out well for us to choose the 0 coordinate to be where the insect has its legs fully extended. That way we get y2 is the height above that. Okay, and we'll give them corresponding velocities here: v0, v1, and v2. So let's do this. Find the upward velocity that the insect takes off with. So, in other words, find v1. We use our acceleration kinematics. v1 squared equals v0, v0 squared, plus 2a times y1 minus y0. Okay, well, y1 is 0, and v0 is 0. So we get v1 as the square root of negative 2a y0. But remember, y0 is negative. Remember that? Negative right there. So you're not going to do the square root of a negative number. It will be a positive number. This tells us it's 4 meters per second. 4 meters per second. Okay, very good. Next, we want to figure out how long it takes for the insect to go from y0 to y1. Well, we can just use v1 equals v0 plus acceleration times time. So the time it takes is equal to v1 minus v0 over a, but remember v0 is 0. So we just get 4 meters per second divided by 4 kilometers per second squared. This is 0.001 second, or 1 millisecond, right? Oh, I forgot to say this, but make sure we already did it with the y coordinate. We converted it to meters. Your acceleration needs to be in meters per second squared, not kilometers per second squared. So you got to multiply that a by 1,000, right? Okay, very good. And then C, how high does the insect jump if air resistance is negligible? So let's use a kinematic. Let's use a different one. v2 squared equals v1 squared plus 2 times the acceleration but it's not pushing off anything, right? It's in free fall, you could say, even though it's moving up. It's under the acceleration of gravity, so the acceleration is negative, and it has a value of g. And then times y2 minus y1. Well, y1 is 0. The velocity at its high point, when it reaches its highest point, the velocity also 0. So we get 0 equals v1 squared minus 2g y2. Solve for y2. We get v1 squared over 2g, 0.816 meters is the answer. So 81.6 centimeters. That's without air resistance, right? But with air resistance, we're told it should be about 70.